Instead, I want to talk about something that I just heard is going on the computer networks, which is some of your guys' Word documents are getting lost. Has this happened to anybody else? Or not just Word documents, but files in general. Who's lost files? My 244s were talking about it too, and I thought it was an isolated event, but Chelsea?
My group project that we have going on at OSU, we lost like a complete file and we couldn't find it on Google Drive at all.
So, okay, it's Google Drive. It's not the RAID system. Okay, and yours was in My Documents.
Word documents.
It was in your Kelly Johnston folder on your computer. You put it in that folder.
Yes.
Okay.
In the school library.
Well, it doesn't matter what computer you're on as long as it's. So here's the deal. Let me show you what I'm talking about, just so you understand. So
My documents in the
that pocket has a hole in it. So let me come in here. Hang on.
Yeah, we know what that's for.
This guy. Did you hear that, YouTube world? Jerk.
He said, we know what that's for.
What a jerk.
The hole in his pocket.
All right, let me show. Oh, so I just did it actually. So here, I just fired up. I fired up. You can't see this. I fired up the computer. Sean Rule, right there. That folder, I know it doesn't look like it, but that folder is in a very, very, very special place. It's called a RAID drive. It's called a RAID drive. Now, if I was to save something and put it on my desktop, like right here, then I can't complain if that goes away. Because the machines get shut down every night, I believe they get rebooted every night, and I believe the way that machines are set up is anything put on the desktop gets washed clean. And there are a bunch of different network drives. If you go into the computer here, there's the N drive, which up until today, I believe was actually down and disabled. Every once in a while, you guys may have noticed when you log onto the computer, down here a little message comes up, could not connect to all network drives. The N drive I don't even know what's on the N drive. Let's click into it here. Banner, campus safety, net apps, budget tracking. That sounds like fun. Look at that.
Anybody can look at it.
What is this Excel workbook for? Standard budget reports. Oh, administrators. Let's close that. Now anyway, this My Documents folder though, it's not called My Documents. It's called Sean Roll, and there My Documents is inside that. So that My Documents folder right there is in a very special place. It's called the RAID disk. Does anybody know what RAID stands for? RAID. It's an acronym.
I used it.
Used to know. How many of you guys still use an alarm clock versus your cell phone? Alarm clocks, me too. What do you often put in an alarm clock in case you have a power outage? You put a battery in your alarm, like a 9-volt battery. So that way if the power goes out, you cut power to the cord, there's a battery in your alarm clock. Even if you don't have an alarm clock with a battery, how many of you have smoke detectors in your house? And nowadays, those smoke detectors are hardwired into the house. But those still have a battery backup. They still have a battery backup because on the off chance the power gets cut to the house, which sometimes happens in a fire, you've got a battery backup. What's it called in most cases when you're powering your alarm clock and you also have the battery? If the power to the plug is working, we say the battery is what?
Backup.
It's a backup, but if it's not actually doing anything, it starts with an R.
Reserve.
Redundant.
Oh.
It's redundant because it really isn't doing anything unless the power gets lost. Then it becomes a backup. Does that make sense, Chelsea? So this word actually stands for redundant. Now you've heard this word before. You've heard the word redundant before. That's redundant. It's like military intelligence. It's redundant. Okay? So the idea is redundant means it's not doing anything so long as the original system is in place. As soon as the original system gets pulled, then it becomes a backup and it becomes necessary. But while the original system is there, it's working. Same as a nuclear reactor has a bunch of these usually. They've got a valve, and then a backup valve, and usually a third backup valve, because you do not want that kind of crap leaking out, then you get Fukushima and awful things happen. The other words are array of independent disks. That's what RAID stands for, Redundant Array of Independent Disks. The reason this is such a good thing is COCC has 6 of these things. I'm going to draw them as circles because that's what I believe a hard disk still looks like unless they're going to flash-based ones. Little spinning disks. When you save something to the My Documents folder, it goes to all 6 of those things. So it's backed up with 5 backups, essentially. It goes to the first one, and then it's copy, 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 copy. Why is this good?
Because you can lose 5 and still have your.
Because you can lose up to 5 of them, and you don't lose anything. And you don't lose anything. Now here's a question. Suppose the chance that this disk fails is a coin flip. Which it's not, but just suppose that it is. Now that would mean that all of them are coin flips. If it's a coin flip, what's the chance you're going to lose it? I learned right there. Park in this pocket. If it's a coin flip, what's the chance that your data is safe? Well, that means half the drives are going to fail on average, right? On average over time, half the drives are going to fail. So in other words, good, Mike, thank you. Let's define what 1/2 means. Let's say that there's a 1/2 chance over any given year that one of these drives is going to fail. So you're going to expect half the drives to fail, right? You're going to expect half the drives to fail, which means 3 are going to go bad, 3 are going to be fine. Is your data okay on that case? On average, your data's fine. But what's the actual chance that you're going to lose data, or you're going to get? So I like where Jacob's going with this. Let's figure out the chance that we lose our data, because what's the only way we're going to lose our data? If all 6 fail, excuse me, I drank a lot of pool today. If all 6 fail, we lose the data. Any other case, the data's fine. So if okay, fail, okay, fail, okay, fail, totally fine. Data's fine, right? Fail, 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 okay, okay, fail, totally fine. How many different outcomes of failing and not fail? Sorry, I'm slamming on the walls here. How many different outcomes, based on your last project, would there actually be with okay and failing? Does anybody remember the answer to this one? I don't think I made you do this one. And I wouldn't have made you do a tree diagram for it because it's a little ludicrous. How many options for each disk?
2.
2, right? Okay, fail.
2 times
Times 2,
2
times 2, times 2, times 2. 64 equally likely outcomes. From all of them are okay to all of them fail, yes? 64 equally likely outcomes. How many of them are bad for our data's point of view?
30.
Only 1.
Oh, yeah.
And why is it only 1? Because when they all fail, every other, if you imagine the tree, okay, fail. 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 It's going to get ridiculous pretty quickly. But only 1 of those branches goes fail, 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 fail. 1 of the 64 is the chance we lose our data if all 6 drives fail, right? Over 6 drives. That's not good enough for a network. 1 in 64 is, what does that end up being, like 1.5% or something like that? 1.5%? That's not good enough. That means over 100 years, about once every 100 years, you're going to lose all your data. Although it sounds like that might be happening right now. COCC is about 100 years old, isn't it? COCC is going to turn, well, no, it's not quite 100 years old. It's like 60 years old, isn't it? But here's the thing. The chance that one of these things fails is not 1 in 2. That is, it was quoted. I actually asked the IT department because I was interested. I said, well, so what is the chance that one of these things fails? And they said, oh, dude, it's like 3%. I said, it's 3%. I said, well, okay, it's 3%. That means on average, you could expect 3% of the drives to fail any given year. Which means on average, none of them are going to fail. What's 3% of 6? It's 0.18 of a drive? Whatever the hell that means. I don't even know what that means. It doesn't mean anything, right? So, we feel pretty good about that. But isn't there still a chance that they could all fail? So what is the chance they all fail now? Now, some of you might say, Rule, it's still 1 in 64. But we can't say that anymore, because the reason we had 1 in 64 was because it was 50-50. It was a coin flip. Now it's 97-3 all the way along, yeah?
So then it's just like the chicken.
Then it's exactly the chickens. I just bought 6 birds and I got 6 roosters. I just bought 6 birds and I got 6 roosters. A rooster being data failing, or hard drives crashing and data failing. So what's the chance that you got 1 rooster? This one fails. What's the chance that one fails? Be brave. It's 3%. So you first have to be unlucky enough to be in that 3%. So if you're imagining your tree diagram, it's 3%, 97%. We can ignore this branch, because this branch is full of data not being lost. Let's focus on this branch right here. That one splits again, right? To okay, fail. And I'm going to ignore that okay branch, because I'm interested in losing all my data, right? So what's the chance of the second drive failing?
3%.
Again, 3%. So here's the chance of the next drive failing following the first drive failing. So this is extraordinary. This is 0.0009, which is now extraordinarily unlikely, yes? What's the chance the next drive fails? 3% again. Now we're up to 0.000027, I think, if I got the number of zeros right, I think. So now it's really unlikely, but we have 3 more drives to go to fail, don't we? Because there's still 3 more that can be totally fine. On average, we said they would be. But if I want them all to fail, I've got to have that many 3%. So now I've got 0.000000. I can't do this in my head. What's 27 times 27?
Who knows?
Say that again, Jeremiah. I'm sorry.
I think it's 9 O's.
9.
If I'm reading it right.
You probably are. Is it 10 to the negative 9?
Yeah.
So what is it? What times?
7.29 to the negative
I think 7.29 times 10 minus.
It's actually going to be 8.
10.
It's because it's 10 to the negative 9th, but the decimal point is between the 7 and the 2 9. So you got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that correct? So 7.29 times 10 to the negative 9th.
I guess it's negative 10.
Oh, then Jeremiah, I apologize. 1 more 0.
So it's 9 zeros.
It's going to be 9 zeros because the decimal point is between the 7 and the 3. So the first one is going to get you off the 7, and then you pick up the extra 9 zeros. But even if we got the 0 wrong and had 1 fewer or too few zeros, that's the chance, friends, you're going to lose your data. That's the chance you're going to lose your data. Which means, what's the chance you're not going to lose your data? Not lose. 99.999999926. Essentially 100%. So you can expect to lose your data roughly 73 times every billion years. Remember if I'm reading that correct? 73 times every billion years? If I'm reading that correct. So when you guys start telling me that you're losing data, I start going, you shouldn't be losing data. Now when I hear it's in the cloud, I'm like, okay, this is not cloud stuff we're talking about. I'm sure the cloud has a redundant array as well. I'm hoping it does. But I don't know anything about it. I do know COCC's RAID disk network is backed up. I cannot define why a file would have been corrupted and not lost. This is just talking about losing a file or the drive's going down. So I don't know what's going on there, unfortunately.
Oh yeah, it flash warnings. I haven't seen the warning.
I gotta talk to the IT department and find out if the numbers are still 3%.
They called it a
Maybe it's
glitch.
93%. They called it a glitch. Well, there's a chance of a glitch.
Yeah. Well,
You
maybe
just
they
calculate the
used
chance of
wrong
a glitch.
terminology.
No, but that's the thing. That's the thing is,
I thought it was a bug in there.
you be quiet.
I thought there was someone got in there.
That's
or
possible.
virus.
They could have hacked it. They could have, that would go outside of what the
Right,
definition of a
that's-
RAID disk
Makes
is.
sense.
That would be. So I don't know. I mean, I wish I had a better answer. I don't know, but I don't know, unfortunately. So in other words, you guys got 6 roosters, which is highly unlikely. It's highly unlikely to get 6 roosters, basically. So if you get 6 roosters, then you start questioning, maybe the probability is wrong. Because if I bought 6 birds and got 6 roosters, maybe the people at the shop are giving me the wrong data. It's not 90%. It's more like a coin flip in that case. So the math you're learning about right now is easily applicable out into the world. It's also easily inapplicable. I'm going to share with you before break here. before 5:30, I'm going to share with you a way this was actually misused. Then we'll come back and start talking about dice. But there were a few years ago. This is in the 90s, I think it was, late 90s, mid to late 90s. There was a London lawyer named Sally Clark who lost a child to SIDS. In English, she's English. They call it cot death over there. You know, that baby just goes to bed and dies in the middle of the night. Unfortunately, one of my friends from back east just had this happen. It's freaking heartbreaking, especially when you know the person. I mean, it's just, you know. So, I mean, you can imagine. Maybe you can't. I don't even know if I can imagine. It's one of those things when you hear and you go home and kiss your kid because, you know, you're just so thankful. So, she lost their next kid to SIDS again. Like 2 years later, lost a second child to SIDS. Then she was put on trial for murder. So add that, right? Insult to injury. So here's this woman trying to deal, and her husband trying to deal with the loss of 2 children. Then she's tried for murder. And her question, as it should have been, was, why are you trying me for murder? Why are you trying me for murder? And she says, well, the chance of SIDS in England is something like 1 in 8,000. So that's a chance of, I'm going to make light of this only for number's sake. That's getting a rooster is 1 in 8,000. So that's very unlikely, yes? 1 in 8,000 is a chance of SIDS. So the lawyers, and this went to court, and made it through court, said the chance of 2 SIDS cases is therefore 1 in 8,000 times 1 in 8,000, 2 roosters, which would be 1 in 64 million. Now 1 in 64 million is essentially 0, which means there's no chance that both of your kids could have died from SIDS, which means they died from some other way. And that, for the jury, was reasonable doubt enough to cast aspersions on the SIDS, and they said that means we suspect foul play, put her in prison. She spent, I think, 1 year or 2 years in prison before the statistical world finally goes, what the hell just happened? This is BS. And they went back to trial. They opened the case again, and here's what they picked on. You see that word RAID up there?
Yeah.
That word RAID? The most important word in that acronym is the I, the independent. This. The disk is a description of what it is. The redundant is very important because it's the backups. The array is just because there's more than one of them. It's the independent. What does the word independent mean to you? Say that again.
Singular?
In what way? Go with that again, Jeremiah.
Like nothing else. Doesn't depend on anything else.
Boom! That's exactly what it means. It means if this drive fails, that drive doesn't care. It keeps spinning along just independently of any other drive. That's what independent means. And independence is one of those things you shouldn't assume in a natural system. In a system like this, you've created the disks to be this way. You've got them hooked to different circuits. You've done everything you possibly can do to make them independent of each other. Here's the trick. What the news didn't report on in England back in the 90s was that during the same time period that Sally Clark and her husband lost 2 kids to SIDS, 6 other families did too. She was a lawyer, though, a high-ranking lawyer, so of course the news loves that, right? The news loves to bring down somebody in power. So she was brought to trial, so the statistician said, wait a minute, there are 6 other cases of double SIDS, multiple SIDS deaths in England. How can you use the 1 in 64 million argument when it's really 1 in 7?
Yeah.
1 in 7 is 14%. That's not unusual at all, right? And they said, well, wait a minute, where are you getting your 1 in 6? They said the same records you had access to but chose to ignore. And then the original prosecution said, well, I don't understand why our math didn't work. And the statisticians very carefully explained. You assumed that the 2 deaths were independent of each other and never bothered to check for genetic markers in the children. If a child dies of SIDS, most likely, and this was a study that was brought up, there's a marker that one or both of the parents are carrying that makes the children more likely to die of SIDS as well. I didn't know this. This is all news to me. So in other words, you can't just treat the second child as a 1 in 8,000 or whatever it was chance, because it was almost a certainty, a statistical certainty. If the first child dies of SIDS, the next child is also kind of susceptible to the same unfortunate turn of events. But they assumed the independence of the 2. Now that's okay with things like throwing dice, flipping coins, pulling a chicken out of a bin. That's okay, unless there's some goofy genetic thing going through the chickens. But it's not okay when we talk about biology when there are all kinds of cellular links. Now, the good news was Sally was let out of jail, thank God. She had to go back to put the rest of her life back together. The bad news is she became an alcoholic and she died within 3 years of being released back out. So, I mean, this is an extreme case. It's an extreme case of mathematics gone horribly wrong. But it's also a case of the power of mathematics and how you can actually use it to fight for the forces of good, if you will. I just wish the statisticians had gotten to the original trial and didn't have to wait until the counter trial. So, very powerful mathematics. They need to impress the hell out of all of you. I'll literally press that. I got starbursts. We can bust those out later. Sorry. Sorry. Anyway, let's take 5 now that it's 5:35, and we'll come back. We'll learn.